record. All right. I think we're in the money now. All right. So let me just 2, 4, 6, 8, 10. Okay. We're getting there. It feels like there's not very many of us here. There aren't. But I think there's only 3 more people who are supposed to be here that aren't. It's pretty good. So anyways, let me move that to the side here. All right. First things first, I did yesterday, I kind of buckled down and got our Moodle page sort of set up. Let's see here. Who's there?
Did you steal my lecture?
Do you need this one?
I use a lecture. It's okay. I was like, hey, where's my lecture?
I've got a super angled one.
This one has a massive one.
I know. Oh yeah. Did they tell you?
Yeah.
I was like, welcome to calculus. Their jaws drop.
Yeah. First come, first serve.
Well, no, if you,
Kenya.
Emily, nice to meet you.
Nice to meet you.
If you need it,
That's fine.
or I've got a super angled one, but I can't write on the.
Late on Thursday.
See ya. I knew there was going to be a brawl. No. Anyways, everyone wants this one. It's perfect. Okay, yeah. So what was I saying? I set up the Moodle page finally yesterday. So now what's confusing about this textbook, the only thing that I don't really like is that they don't label the subsections, right? So if you're looking, well, I mean, you probably don't have the physical copy, but under chapter 1, for example, it just lists the subsections. So, but it doesn't do like 1.1, 1.2, 1.3, which is kind of annoying because then I could just refer to those. But what I've done is for today in chapter 1, we're going to do elements of structured data. We're going to do rectangular data. Seems the same thing to me. And then we're going to talk about estimates of location, right? Which is what we're going to focus on. Location being center, right? We know the mean from before, right? But we're going to kind of expand on that. So this is all, basically this whole textbook, a lot of it is review from 230. We're just taking a different approach. So what's really nice is you have a lot of these concepts from 230 and it just lets us build on those, but also kind of explore kind of more of the data science part of it. Okay, and so I have outlined what we're doing each day. It gets kind of long because I could have just said 1.1 to 1.3, but no, they want to just have names. So I said, fine. Okay, we're going to do the whole textbook, right? Works out perfectly. Huh. And I've also outlined the labs. Some of these labs I have made, but because I kind of rejigged some stuff, I don't have all of them made. So hopefully that all works out. But anyways, that's on me. And of course, I managed to forget that we have some Fridays with no classes, right? So that kind of bumps our labs for those chapters, but that's okay. It all works out. Okay. What I did last term is I started with kind of review of regression and things like that, but we're going to get there. So what I did was instead I gave us more time kind of around week 7, week 8 to spend more time on that, because I know we didn't really have a lot of time in 230 to talk about that. It is so important. And so I've kind of spaced it out a little bit better so that we will get there, I guess is what I'm saying. All right. So in terms of pre-reading, right, I want you to kind of read chapter 1 and then we'll start chapter 2. Holy smokes. It's a long one. Or maybe they're just long concepts. No, looks like a lot, but I think it's just little itty bitty sections. Okay. So I do want you to be reading ahead, right? Same ideas for 230. Just because if when we talk about it, if that's the second time that you're hearing it, then that's so much better than if it's the first time. Then it's like, whoa, what's going on here, right? In the beginning, it's all kind of review, right? So that's fun. But later on, right, pre-reading is going to be important, or at least skimming, right? So you kind of have an idea of what we're going to talk about. Okay, so usually I do a little bit of like administrative things here, but I don't think there's anything to talk about. Week 1, done and dusted. There we go. Chapter 1 is called Exploratory Data Analysis. So that's of course where the story begins always, is we get some data set and we have to kind of poke around and see what's going on in here. What does the data look like, of course, but also is there anything interesting right off the bat that we could find there? And I think I hear the back door is open. It's bad enough I stole her lecture. I've already forgotten her name. Is it Danielle? Come on, guys, you were here. It's in the recording, but that's also in the recording. So I'll have to go back. Exploratory data analysis. You'll hear it referred to as EDA, right? Exploratory data analysis, EDA, cool. But that's the first thing that we're going to do. When we receive a data set, right, the first thing we're going to do is we're going to, import it, have a look, poke around, learn some stuff about the things. No, things about the variables. All right, so EDA is the first thing we do when we are handed a new data set. And the goal is to get to know the data, right? Get to know the variables, but also, what are some expected ranges for these variables, right? And if we think back to, if we have a numerical variable, for example, then I might make a histogram of it, and then I look at the shape, the center, the spread, right? That kind of thing. And so that's all exploratory data analysis. So we're going to take it way back and just kind of go back through it, which is how I've always wanted to teach statistics. In my head, I've always said, okay, for Stat 230, for example, what if we could just introduce all the concepts and then go back over it and fill in the gaps? I just feel like that would be a better way to teach it. There's no time to do that. New phone, who dis? Is that my phone? Oh, okay. I'm always worried it's my phone. Right. And so we've done exploratory data analysis. We just haven't called it that. Anyways. So the goal is to get to know our data. as data scientists, we won't necessarily know much or even anything about the data, right? We could be handed financial data from some financial institution that we've never worked with. So then we need to know what all the variables are. We could be handed, vaccine data, right? So there's lots of different data sets that we could be handed, and that's fine. We can do that, right? Because the tools that we have are all the same. And the first thing we need to do is we need to just kind of get down and do some EDA, exploratory data analysis. I would argue that most of your job is going to be exploratory data analysis, right? Just kind of getting to know the data, or at least half of it is that, just kind of figuring out what's going on, okay? So in terms of what is EDA, we're gonna do numerical summaries, right? But also we're gonna visualize these variables, right? And so, I hate to say EDA again, but I will. EDA are things like numerical summaries, or visualizations, and often both, right? With practice, visualizations, with practice, you'll get more out of the numerical summaries, right? But in the beginning, you're gonna probably wanna focus on those visualizations, right? Because it's easier for us to wrap our heads around. That's why they were developed, right? But for the numerical summaries, for example, if you have a 5-number summary, then the distance between the minimum and the first quartile tells you something, right? And so then you can compare those values. Same thing with the mean against the median. If you have those two numerical summaries, if they're similar, what does that give you a clue of? Tells you that the distribution is likely normal, right? Because that's usually how those two numbers are similar, right? Whereas if it's skewed one direction or the other, or even potentially multimodal, but let's just focus on skews, then the mean is skewed or pulled in the direction of the tail, right? So we're going to get better at reading those numerical summaries and not relying on visualizations so much. They are helpful, right? Especially if you're trying to explain something to a client, for example, right? Then visualizations are a good way to go. But for us, right, with more practice, the numerical summaries are going to be kind of your mainstay, okay? And so, good. But of course, visualizations are nice. The reason I'm kind of hating on visualizations, I'm not, I love them, they're beautiful and they're fun, but they can be some work to put together, right? And so you don't want to be spending all your time in ggplot, or I use the base package if I just want a quick plot of something, right? Then I don't make it pretty, I just use the base plot command. I know, tisk, tisk, tisk. But for our purposes, if we're just trying to learn, then that's good enough. For publishing though, we have to use ggplot and make it look nice and all that fun stuff. Okay, so as a little bit of review, let's talk about the different data types that we have, right? So for the most part, we're going to split our data types or our variables into just two groups, same as we were doing for Stat 230, right? We either have numerical data or we have categorical data, right? We're going to split them a little bit further, but not much, okay? So I'm going to do another tree. That's why I'm hesitating. So it's going to be a tree and then another tree, a completely separate tree that looks weird, but here we go. So if we have our data types, which we usually call our variables, right? But I think I didn't confirm because I'm kind of basing it off of my notes from last term, but this textbook uses data science terminology, right? And so then we would use data types, whereas in statistics, we would use variables. But as long as you remember that they're the same, right? There's going to be a lot of those connections. Probably felt like there was a lot in 230, right? Where I was like, okay, you can call this the response variable, or you can call it the dependent variable, and then explanatory variable and the independent variable. And then we're just going to add to that list now, because data science decided that they're special. Although for me, it felt like, because I did my master's in statistics, right? And so all of a sudden, all these statisticians woke up one day and they're like, I'm a data scientist, right? And so they're all statisticians, really, but it's just kind of this field that's evolved. And then so statisticians were like, wait a second, wait for me, I have little legs. No, right? You guys know that. Wait for me, I have little legs. That's statisticians running after data scientists, even though they were the first. Anyways, whatever. So they developed this kind of new terminology just to be cool, right? And so our data types that we're going to be dealing with are numeric. Usually I say numerical. They like numeric. Fancy. Or categorical. Okay. Numeric or numerical data, right? We could split into continuous or discrete. And in terms of our analyses for data science, the difference in analyses is not huge, okay? And so I'm not going to focus too much on it, but for the categorical, there is kind of a difference. So it's either continuous or discrete. And discrete is whenever you have counts, right? Whole numbers, age is discrete, right? 1, 2, 3, 4, 5, right? Continuous is on this continuous scale, right? But we have this numeric or numerical data that we're working with, okay? And usually, because we know this now, we're analyzing the mean if we have numerical data. Okay? Whereas if we have categorical data, which in general can be called nominal data. I mentioned it in like the first week of classes in 230, so I don't expect you to remember, but nominal data is categorical data where there's no natural order, right? And so, and I remember because of the no and then nominal, right? And so there's no natural ordering to these categories, but then we can specify if there is natural ordering. So first year, second year, third year, fourth year, right? Those are categories, right? But there's this natural ordering, letter grades, A+, A minus, B+, B minus, blah, 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 right? There's this natural ordering that we would want to preserve, especially if we're visualizing it, right? It would be really weird if the college started reporting, letter grades, but it was by B minus, A+, B+, I don't know, I lost them all, right? But we'd want to preserve that order if there is natural ordering, right? And so that's going to be important. And so if we have ordinal data, ordinal data has natural ordering. Right, so for example, letter grades on a scale of 1 to 5. For example. Okay. Categorical data could also, so a special subset of categorical data is if you have binary data. Now, binary data, of course, is the 0-1 situation, a yes, no, there's only 2 possible outcomes, right? And so here, if you have binary data, then usually we call it 0-1 data. I keep thinking that this, but that's actually just on here. It's not on my screen, so it's confusing, but anyways. So binary data is 0-1 data, right? Yes, no, only 2 possible outcomes. Only 2 possible outcomes. We can definitely convert numeric data into categorical data, but of course we can't convert categorical data into numeric data, right? And so you can't ask people what kind of car they drive and then make that numerical somehow. However, you can ask people what their income is, right? Their household income, and then you can make income brackets. Right, and so that's creating categorical data out of this numerical data. So you can go one way, but not the other. Okay. So as a quick note, we often convert numeric variables into categorical variables. Numeric variables into categorical variables. For example, income brackets. But then, of course, it's not possible to change a categorical variable into numerical data. And just as a side note on the side note, if you're converting numerical variables into categories, even if that's what you're using, you shouldn't just get rid of your numerical data, right? You want to keep your original data, and then you want to use the derived variable, right? And especially if you're considering collecting data, I always think it's really weird. I understand why they would want to just give you income brackets, right? But they should probably just be asking what's your household income, and then they create the brackets. But I understand that it's easier. People don't really know what their household income is and that kind of stuff. So then you just ask them for the income brackets. Age brackets. Right, really, we should be asking people what age they are, and then we create the brackets later, but it doesn't always happen. Oh yeah, so just as it is not possible to go the other way, right? So let's just write that down. It is not possible to convert a categorical variable into a numerical variable or a numeric variable. Trying to stick with the text. we think about categorical data, and especially, you know, on a scale of 1 to 5, but not even explicitly so, even the 0, 1 data, right? We usually use numbers as placeholders for the categories, right? But that doesn't mean that it's all of a sudden numerical data, right? Just because we have these numbers, right? And so, right, even what year of school you're in, 1, 2, 3, 4, 5, but those numbers they're placeholders for what year of school you're in, right? What kind of car do you drive? Only because I'm looking out in the parking lot here, right? And so it looks like an Infiniti, a Ford, and a Honda, and a Volkswagen. Infiniti might be 0, Ford might be 1, Honda might be a 2, and Volkswagen might be a 4, right? Arbitrary, but that's how we assign them, because then it makes it easier for us to work with them instead of working with the words. Okay, so for categorical data, I realize I wrote we often, and I'm going to say it again, we often, I'll never commit to all the time, we often use numbers as placeholders. Use numbers as placeholders. Or we can call them indicators as well. Indicators. Right. So for example, 0 is Infiniti, 1 is Ford, 2 is Honda, 3 is VW, Volkswagen, Das Auto. Okay, for example. Right, so we have to be really careful when we're just looking at our data, right? Time to wake up. When we're just looking at our data, we have to be so careful that we don't just mistakenly call it numerical variables, right? So here, be careful. Wait. When determining whether a variable is numeric versus categorical. Because if things are stored as numbers, obviously, if you do a numerical summary, it will give you the mean, and it will give you the median, and it will give you, you know, the standard deviation, but they don't mean anything. Okay. So seems like I'm talking about categorical data a lot, but because numerical data is kind of straightforward, right? It is what it is. And in terms of kind of looking at the data, there's not a lot that we can do, or there is, but once we have looked at the shape and the center and the spread, then there's really only so many things that we can do with numerical data. Then we just move on to the analysis portion, whereas categorical data requires a little bit more finesse and kind of working it a little bit. Okay, so a lot of the analyses that we're going to consider and that we do work with are for binary data, right? And so we've seen it before, right, where any categorical variable can be turned into a binary variable easily. Okay, and so a lot of our analyses I'll say of categorical data is specifically for binary data. Specifically for binary data. Okay. And the reason for that is because any categorical variable can be turned into a binary variable, right? And so the reason is that any categorical variable can be converted into a binary variable. Can be converted into a binary variable. And I'll even highlight that here. Why not? So for example, if the question is something like on a scale of 1 to 5, where 1 is strongly disagree and 5 is strongly agree, for example, those are kind of classic options, then whichever one we're interested in, right, whichever category we're interested in, usually the 5, right, strongly agree. Who strongly agrees with whatever statement, right, or who strongly disagrees, right? But let's say on a scale of 1 to 5, I think we kind of know this type of question, right? This type of survey question, right? Where 1 is strongly disagree. 2 is disagree. 3 is neutral. 4 is agree. And 5 is strongly agree. Then whatever one we're interested in, right, whatever category that's of interest to us in our analyses, that's what we're going to make a 1. Right, and so here, this is our binary 1. Gets confusing, right, because it's the 5 in the original categories, but we make it a 1 because that's the yes option. Yes, they strongly agree. And then all the other ones is our binary 0, right, or not 5. Okay. So you can just lump everyone else into the not that group, right? And then you all of a sudden you have binary data to work with. You've probably seen, so we didn't get to logistic regression in 230, but we're going to go back over it in this course, obviously. But you've probably seen it or heard of it in your other courses, maybe. I know in 300, I think we did a little bit of logistic regression, just kind of introducing it. But that's when you have a binary outcome and you're trying to predict it. But anyways, we'll get there. All right. Oh yeah, I think I mentioned it last day, but if you are working on other courses, and you know, yeah, most of you are here, but in case you missed it, right, the text is just available. It's free through the library, but then you can get the make sure it's the second edition on Amazon, because I didn't order it through the bookstore, but it's fine. Find a lot of code chunks in here, right? That might be useful for your other courses as well. Things like neighbors and logistic regression and all that kind of stuff. So, and if you go, there's a link. Very, go look them up on GitHub, and you can download all the code chunks. So I think github.com/getic/practical statistics for data. You just GitHub, it'll take you there, right? So it is available. It's all free to use, right? I think it has a note that you're not allowed to make money off of the code that they gave you. But you could base it off of that. Okay. So that might be useful, just, I know, for your other courses. All right. So if this is the group that we're interested in, we call this our target group, okay, or our target. If the strongly agree group, oops. Is the target, we make it the binary 1, right? The yes. Yeah. And so target is kind of another way of calling it a response variable, right? Sort of, kind of. It's our target in the sense that it's one of the categories, but kind of new terminology a little bit or a lot. Okay, so rectangular data is exactly the type of data that we imagine, right? So if you imagine an Excel spreadsheet full of data, that is rectangular data, right? Because it is rectangular. Right, and so kind of the most basic form of data that we would consider is rectangular. It's also the most common, so I don't really see a need to specify, but so when we think of data, we think of rectangular data. Right, something that might look like this. So I've got some records, or the rows are records or cases. I think in 230, I call them observations, right? So now we have more terminology, right? Records or cases. And I'm pretty sure, confusingly, data science calls one row a sample. What? That makes no sense. So I'm going to avoid that because it doesn't make sense to me, but I guess they left me in the dust. Still a statistician, I guess. That's okay. The columns then we're going to call them features now, right? As opposed to variables. I'll probably still use the word variables, but we'll call them features or variables. Right, so we're probably more used to calling them variables, but let's get used to calling them features as well. So here, in terms of kind of helping you get there. Because for me, it's different, right? Calling them features as opposed to variables. So if you kind of think about how you would describe them, right? These are features. The average age is this, right? The average income bracket is, or the average income level is this, right? So trying to think of numerical variables, but all I can think of are categorical variables. But anyways, right? Could be categorical as well. Think about describing features. Such as average age was 30, 40% were smokers. Right? Age is numerical. Whether they smoke or not is categorical, right? So, right, so now you're describing these features of the data. And in general, right, in R, but also in Python, the data set, we call it a data frame. A data frame is rectangular data. It also means that you have indices, but that doesn't apply to us. So it's like from way, way, way back when you only had R, the console. So when I was learning R, you know, the little console down in the bottom left-hand corner, we didn't have RStudio, so scrap that. All you were talking to was the little console and whatever output you got there, and that's it. So you kind of had to like wrap your head around what the data set looked like and that kind of thing. So, so now the default is a data frame, but it's a data frame. But a data frame is rectangular. Okay. We're going to assume that we just have rectangular data. There are instances where we don't have rectangular data, but we can usually massage it a little bit to make it rectangular. So then it's not really a big deal. Right, so for our purposes, we're just going to focus on rectangular data, and that's all there is to say about that. So in this course, we will assume we have rectangular data. I guess I've got a note here. Non-rectangular data is possible, obviously, but we're just not going to consider it. Right? It's pretty rare, and like I said, we can usually massage it to become rectangular. So, an example of non-rectangular data would be sometimes for time series. If you have more observations on some people than others, for example, or you know, maybe we ask people, how many animals do you have at home, right? Usually some people have lots of different animals, others don't. I'm trying to think of, so in my mind, I've already made it rectangular by making all the different types of animals binary, right? So you can see how it's easy to make it all rectangular. But let's just be aware that non-rectangular data exists. Rectangular. Now that's interesting. Is possible. but we will not consider it here. We learned that really our goal in statistics, but also in data science, is to be able to predict things, right? Predict some outcome, right? I had to say it, even though I was trying to avoid the word outcome, right? We're trying to predict something, some response variable is what we're trying to predict. Now, whether that's a numerical variable or a categorical variable, right? Our main goal is to be able to predict what would happen, right? Or what's most likely to happen, right? If I'm a female, age, I think I'm 36, I don't know, I can't keep track, keeps changing, right? And so, and you know, I live in Kelowna and all these demographic variables, right? If I put that in and I'm trying to figure out maybe how much money I make, right? Then those factors would all be used to try to predict how much money I make. We will often want to predict, well, that's going to be key. We will often want to predict, I'm going to highlight predict an outcome or target, right? We already saw the word target, but target is specifically for categorical outcomes, right? Whereas an outcome is for numerical outcomes or numerical variables, response variables. Let's see here. Numerical data or a target for categorical data. Yeah. And in general, we've called this just the response variable generically before, right? So we'll often want to predict the response variable, but now we're going to specify, okay, depending on what type of variable the response variable is, then we're going to call it an outcome or a target. So we're really just getting more specific into what we're saying. Yeah. So then we say that features, right, which we introduced already. Features are used to predict the outcome or the target, right? So like explanatory variables, but now we're going to call them features. Features are used to predict the outcome or target. And it's like the explanatory variable. So a little bit new terminology, but these aren't things that we didn't already know, right? We already knew these things. Okay. So got our data set, right? First thing we're going to do probably is use the summary command, right? To develop this numerical summary. A summary command includes things like the mean and the median. I think it does both by default, right? Love it. Nice. And then I think there's like a fancy package you could use that would give you more, and you can ask for more. But in general, the default is 2 measures of center, which we're now going to call location, right? And so the location is really what we were calling measures of center. Okay, and so for estimates of location, really what we mean is we mean measures of center. Now, in 230, it's enough to say, okay, well, if we have a normal distribution, then the mean is appropriate. We're allowed to analyze the mean, and we can just go ahead, and the mean is everything, right? And so as long as we have a normal distribution, we can go ahead and we can just talk about the average all we want, right? And a lot of our analyses, that's all we're interested in anyways, right? And then we said, okay, well, if you don't have a normal distribution, then you should use the median, right? But what I want to do is I want to kind of introduce a few other options that are a little bit more sophisticated, right? So if you find yourselves in a jam for your measures of center and the mean isn't quite appropriate, and I'll talk about some reasons why it wouldn't be, then you're going to have some other options, right? But let's start with the mean. The mean is, of course, just the average, right? But it's only appropriate if you have a normal distribution, right? So for a normal distribution, and then we also know about the median, right? Which is if you sort your data, it's the central value, right? We used our my patent pending boop, boop, boop method, boop, 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 boop. That doesn't really work if you have a huge data set, right? Works if you're doing it by hand. But the idea is the same, right? So then R would just take your data and sort it and split it in half and then find the median for you, right? And so the median is the central value after sorting. And there's things like you would take the average of the middle 2 values if you land on 2 values, right? R does kind of a weighted thing, right? So unless the distance is equal between those 2 points, it goes a little bit more towards the other one. It does like a fancy thing. So, but in general, it's going to be the central value after sorting. Okay. So these, and maybe even the mode too, but I'll say here, these are both from intro stats. Okay. Or whatever we're calling that course now. This is for skewed distributions, or maybe I should say for non-normal distributions. For non-normal distributions. I basically just made it binary, right? It's either normal or non-normal, right? Whereas the non-normal, it could be skewed to the left, skewed to the right. It could be bimodal, could be long-tail distribution, right? There's lots of options. Okay, but in general, this is the only distinction that we made between the two. And that's it, it's sufficient. It's sufficient for the most part. And let me just go like that. Yeah. So that'll get us by. Okay, plenty fine. Okay. I never really talk about the mode, but usually if people tell you, oh yeah, I took a stats course one time, And then they usually say mean, median, mode, that kind of stuff. I'm like, right. First week stuff. That's all people remember, I guess. The mode, I think I mentioned it. It's where the peak of the data is, right? So it's the value that has the most observations. That usually only applies to categorical data, right? So if you've got your categories, the mode is the one with the most observations, right? And so it's usually just for categorical data, but it works for numerical data as well. But it's the peak of the distribution, right? So the one that was most observed. And just as a heads up, used mostly for categorical data. Yeah. So we don't really use that one so much, right? But it's an option. Yeah. What are some other options for our location, right? Location is what we're going to be calling the center, right? Where is this data located? So another option is a weighted mean, right? Your grades are a weighted mean, right? 15% are from your labs, right? You have some lab grade and it's assigned some weight. And then I can't remember, 20% from your assignments. I don't remember your grade breakdown, right? But so then these grades are all weighted to make an overall weighted average. And that's your final grade, right? Because some things are worth more than others, right? And I can't remember I think assignments are, is it 15? I think. And then or assignments, whatever. Some are worth more than others, just because. Okay, so the weighted mean. Each value is assigned a weight. Then take the average. Right, so your final course grade is a weighted average of the different components. Right, and so your final course grade is a weighted average of your course components, let's say. So a weighted mean, you would use that if you want to downplay some observations or potentially kind of amplify some other observations, right? So here you would use this when we want to downplay or amplify, right? Depending on what you want to do. But the weights all have to add to 100, right? Otherwise it won't make sense, right? And so you're going to kind of downplay some and kind of amplify other observations, right? And so when we want to downplay / amplify one way or another, observations in our data. Maybe you just value a certain group's opinion more than others. And we even kind of do this if you're working with a client, for example, right? There's the main stakeholders. You're going to value their opinion more than, you know, the random people that you kind of talk to in the hallways and that kind of stuff, right? Because they're the ones who are paying you and making decisions and giving you the go ahead, right? So then we amplify those observations and then we kind of downplay the other ones to even it all out, right? Not a concrete example, but we do it kind of internally, right? Other measures of location would be things like percentiles, right? So we've used percentiles in terms of the quartiles, right? Spread. But also we can use the percentiles for location, and I would argue as well as spread. But the percentiles, the pth percentile, right, has p% of the data below it and 100 minus p% of the data above it, right? And so the pth percentile has p% of the data below it and 100 minus p% above it. Right. And the data is sorted, of course, otherwise it wouldn't make sense. Okay. So you'd have to sort your data. We have already talked about a special case. So the 50th percentile is, of course, the median, which we know and love. Right, but we're also familiar with some other percentiles, right? The 25th percentile is the first quartile, right? And so, like I said, sometimes knowing the location of the first quartile or the 25th percentile in relation to the 50th percentile, that gives you an idea of the distribution of the data, right? So it's kind of takes you there. The median is the 50th percent. 50th percentile. Right, and then Q1, which is the first quartile, remember, is the 25th percentile. And Q3 is the 75th percentile. Right. Those are just some of the ones that we've already seen in the past, right? And they're just special percentiles. But in general, right, we can use the percentiles to find locations of these cutoff points. We can also do a weird thing called the weighted median if we wanted to. I don't really see a point, but we can. And it is an option. The weighted median is exactly what it sounds like. We assign weights to our sorted data, and then we split based off of those weights. Right, so we have half the weights on this side and half the weights on the other side. So if you're emphasizing kind of higher values or kind of later values, then the split would come later, right? So that would be the location. But it splits the sorted data. Of course, if you ask R or Python to do these, it'll just sort it for you, so you don't have to. But it's good to be aware. So splits the sorted data in half based on the weights, assigned. think the last one I want to mention, which I think is the most interesting and kind of the newest, coolest one, is the trimmed mean. Okay, and so the trimmed mean, it drops or trims off some extreme values on either end of your data set, right? So it does sort your data, but the trimmed mean it trims or drops a fixed number, or usually we do a percentage. So 10% trim mean, 5% trim mean, that kind of thing. Trims or drops a fixed number or percentage, right, of observations from either end of the sorted data. From either end of the sorted data. Okay, and then it calculates the mean of those values. There's benefits to that, right? But here I'll say then calculates the mean, right? If we're lobbing off these extreme values, right, we know that those extreme values could be what cause the distribution to be skewed, for example, which is the only reason why we wouldn't be able to use the mean, right? Is if we have a skewed distribution, which means we have these outliers on one end or potentially on both ends, but in a weird situation, right? So if we trim those off, all of a sudden we might have kind of a more robust data set, right? Where we're not being pulled towards those outliers anymore, right? And so now we're able to use, we can use the trimmed mean in our analyses, even if we have kind of a skewed distribution. Okay, so that's kind of cool. So by removing, and maybe I'll do this on a long blurb here. By removing potential outliers, back in action. Potential outliers from the calculation, we get a robust estimate, right? We've used that term robust before, but it just means that it can handle outliers and it's not going to be pulled in the direction anymore, right, of outliers. So by removing potential outliers from the calculation, we get a robust estimate that incorporates more data, right? Because the mean looks at all the points, right? As opposed to our only option up until today, or maybe, but that I've introduced at least, is the median, right? And the median only looks at the central 2 or 1 values, right? And then that's it, right? Here's the middle, and that's not necessarily the case, right? Whereas the mean takes into account all those numbers, right? And so we get a robust estimate that incorporates more data So even though we had to lob some off, right, we're still kind of able to use most of the data, as opposed to the median, which we know is also robust, right? But it only considers the central value, which is also robust. Oops. but it only considers one or two data points and ignores the rest. It uses them for to find the middle, but then after that, we don't care anymore. Ignores the rest. So you can see the benefit of using the trimmed mean, because then you're able to use more of that information. Let's just highlight here, robust is of course important, right? Robust means that it isn't swayed or kind of pulled towards, outliers. Outliers / extreme values. Extreme values aren't necessarily outliers, but usually. I called them estimates, right? Usually in statistics, we call them estimates, but I have a note here. In data science, we call them metrics, right? Kind of a fancy term. And so here in statistics, we call these measurements, right? Those location or measures of center, I would call them. We call these measurements estimates. Whereas in data science, we're going to start calling them metrics. Whereas in data science, we call them metrics. So by that, I mean things like the mean, the median, the trimmed mean, etc. They're just metrics. Good. I did it. I said all I wanted to say for today. Any questions? No? All right, nice work. See you on Thursday. Stop this recording here.